have to talk about some vocab before we dive into this. And that is an included side. And all that is the side formed by two angles. I also like to think of it as a side that's in between two angles. Okay? So, for example, we have angle R right here and angle T. Okay? Which side is in between or made up of angle R and angle T? Which side? Or which side are R and T both sitting on? Line TR. So line TR, or RT, however you think of it, is the included side. When we mark it, it's a side that's in between two angles. The third shortcut we are going to talk about is angle, angle, side. Meaning, if two angles and the included side, so the side in between them, of one triangle are congruent to two angles and the included side of another triangle, then those triangles are congruent. So something like this. You have an angle and a side and an angle. Angle, side, angle. Two angles with a side in between. Similar to side, angle, side, but reverse. The other shortcut we're going to talk about is angle, angle, side. Meaning if two angles in the non-included side of one triangle are congruent to the corresponding two angles inside of a second triangle, then those two angles are congruent. Those two triangles are. Meaning something like this. If we have, we'll pretend this side is not marked. You go from an angle to another angle to a side. Angle, side, or angle, angle, side. So two new shortcuts. Angle, side, angle, and angle, angle, side. One other new vocab word, it's a new reason we are going to use or can use when we're proving triangles are congruent. And that is CPCTC. That stands for corresponding parts of congruent triangles are congruent. We use this reason when proving that parts of two triangles are congruent. So whenever we're given a proof and we're given triangles, and we're trying to show that their sides or their angles are congruent, we use this reason every time. So it's like another freebie. Okay? Because if two triangles are congruent, then their parts are congruent. Okay? CPCTC. Because you're given word banks with your proofs or multiple choice type questions, you don't necessarily have to worry about the exact letters. Just know that, oh, I'm going to pick the thing that has a bunch of C's, a P, and a T. Okay? But if you want to remember what the actual letters are, here's a little saying that someone had told me once to make it helpful to remember. Cool people count their coins. Okay? CPCTC. Cool people count their coins. You don't have to worry about it as much now because we have word banks. Or it's going to be written there for you. But we used to have to memorize that. So it used to be a saying, but just look for that, those letters. Okay. CPCTC. Corresponding parts of congruent triangles are congruent. Okay. Questions over that? Okay. You might have noticed that we have not used angle, angle, angle. Okay. And some of you maybe are thinking this in your head, wondering when we're going to be able to write this. But we never use angle, side, side. We never use that. Think about it, laugh about it. Yeah, we can't use that in math class. We're not going to use it in math class. Okay? We're not going to use angle, side, side. Or side, side, angle. Okay? I just got it. We don't use it. You're writing it in an appropriate word. We're We're not using it in math class, okay? Let's think about why though. Some of you might be like, well, why doesn't angle work if all three angles are the same or if the triangle's the same? All right. Can anyone give an example of why that wouldn't work? All the corresponding angles are the same, but they're still not the same triangles. Anyone have an idea of why that wouldn't work? Yeah, very good. They could be different sizes. Very good. I like how you use dilation there. Because they can have the exact same angle, and I like to use equilateral triangles as this example. Because what are the measurements of all equilateral triangles? They're all what? They're all the same, they all equal. Well, individually they all equal. How much? 60. Right? So this is an equilateral triangle. Well, this is also an equilateral triangle. But are they the same exact triangle? No. They're two different ones. You can have little equilateral triangles, and you can have really big equilateral triangles. Their angles are the same, but their sides aren't. Okay? So you can have triangles with the same exact angles, but their sides are different. So you can draw the diagram to show or write out that reason. That's why angle never works, because you can have triangles where all the angles are the same, but that makes them similar. It doesn't necessarily make them congruent. So we can't use that as a questions over that. So let's look at some just examples of trying to determine what shortcuts we can use. So we take a look at A. I have an angle, a side, and an angle. Do I have that same exact pattern in the other triangle? So I have an angle. Do I have a side next to that angle? No. The side's over here, right? We have an angle. The side's not marked. And then an angle. And then a side. So do they have the same pattern in each triangle? No. So can we say that these triangles are congruent? No. So there's none. They might be congruent, but we can't really use a shortcut to say whether or not they're congruent. Some of you might be thinking, well, I see that there's an angle, side angle. But you have to be very careful. There's a rule I like to say. You can only skip one thing. Okay? So if we take a look at this triangle WSJ, some of you might be thinking, well, here's an angle, side, angle. But look, we skipped to go this direction. We skipped a side, and we skipped an angle. We skipped two things to get here. Okay? You can only skip one thing. So here, if we go the other direction, we have an angle. We can skip this side and then go to the angle. We're allowed to skip one thing. But if you're like, we skip this side and then we skip this angle, we're skipping two things, you're not allowed to go that direction. You can only skip one thing. So that's why none of these work. Okay. If we take a look at B, how can we say that these two triangles are congruent? Good, we have vertical angles, and we know they're congruent. We got that. So let's mark it. Now that we've marked those angles, which shortcut can we use? Side, side, side. Side, angle, side. Angle, side, angle. I only see one set of sides. Angle, angle, side. We have an angle. Then we have an angle. Then we have a side. Angle, angle, side. And if you think, well, isn't it angle, side, angle? Well, if we go this way, we have an angle. Nothing here. Nothing there. There's nothing marked. So we skipped 1, 2. We can't skip two things. Okay, so that's why we have to go the other direction. Angle, angle, side. Okay. And what can be used in C to state that these triangles are congruent? Might be more than one. What's one of them? What shortcut? share a side. Okay, I'm going to mark it. Okay, what shortcut? Is it side, 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 side angle? What can we say? Well, that's only if we're saying parts, not triangles. Angle, side, angle. Here's an angle. Here's a side. Here's another angle. Angle, side, angle. Is there another one we could have used? Okay. Well, we already said angle, side, angle. Oh. What's another one? We can sit here for half an hour trying to answer this, so we can throw some answers out there. What other one can we use? What? Side, angle, side. Good. I see a side. Then I see an angle. Then a side, side, angle, side. Could we have used another one? Side, side, side. Very good. These two sides are the same. These are both 4, so they're the same, and they shared this side. Side, side, side. Is there another one we could have used? Angle, angle, side. Very good. We have, I'm going to erase what we marked. We have an angle, then we have an angle, then we have a side. Angle, angle, side. They all would have worked on this one. Okay. Any shortcut would work on that one. Okay. Oh, I know what D is. D is really easy. All 3 angles are the same. I'm going to say angle, angle, angle. You want to write that down, right? That's what we want to use.
No.
Doesn't work. Yeah, don't do that. Even though it has all 3 angles, it doesn't work. Because they could technically be similar. They didn't indicate anything about any one of those sides being the same. So you just can't assume things. So nice. Angle, angle, angle does not work. Can't use it. Nothing could be similar. You have to have at least one of those sides in there saying that they're the same to conclude that they're congruent. Okay. Questions over that? Okay. So let's start using this in proofs. So we want to complete the following 2-column proof. We were told that L is the midpoint of WE and WR is parallel to ED. Right? And we're going to prove that these triangles are congruent. So at least fill in the skeleton or the bones of your proof. So what's our first statement every single time? Given. So L is the midpoint of WE and WR is parallel to EB. And our reason for that is given. Okay. What is our last statement every single time? What you're trying to prove. And then we know 5 is going to be one of those shortcuts. Right? Side, 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 angle, side, or one of the 2 ones. Angle, angle, side, or angle, side, angle. Okay? So now we have to fill in the rest. And again, I like to fill in my reasons before I do anything else. So they didn't tell me that anything was congruent to each other. So I can't mark it in my diagram. But I was told that L is the midpoint of WE. Trent, what does that mean one of our reasons is? Definition of a midpoint. We have a vocab word. Our reason's definition of that vocab word. By just noticing that, you get another answer. Vocab word, definition of that vocab word. Please get that down. Okay? The preview. Okay? Took care of it. Done. Check. Took care of that bit. So now, it's stating that WR is parallel to ED. I'm going to mark it with arrows. That doesn't mean they're congruent. It means they're parallel. And we talked about it last week, and last week was a weird week with the snow day, and then I wasn't here on Thursday for the meeting. But we talked about it last week. Whenever we're given parallel lines, What is our reason and our proof like 99% of the time? It's not definition because not vocab. Symbol. Not for rule. Not for parallel lines. Something else. What reason? We talked about it. It's okay to remember because it was a weird week. We have parallel lines. Our reason, like 99% of the time, is going to be alternate interior angles are congruent. Whenever you're given parallel lines, another freebie, alternate interior angles are congruent. Took care of that. Got that reason. We'll talk about what to put in for the statement, but at least we have the reason down. Okay. Then, what type of triangles are these? So, these vertical angles are congruent. Yeah, remember, bow tie triangles always mean vertical angles are congruent. So, you just remember those little facts? You filled in most of your proof. You filled in 60% of your proof. That's technically passed. Pass that question. By just doing that, pass it. Do that on every single test. You do 60% on your test. Oh, that's not bad. Passing is not great. It's passing. Okay. But then we have to fill in our statements and mark our diagram to figure out our last reason. Okay? So let's go back to this reason right here. Definition of a midpoint. If L is the midpoint of WE, what can we conclude from that? L is right in the middle of this segment. So what can we conclude? Yeah, what are the same? Yeah, the two pieces are the same. If L is directly in the middle of WE, then I know WL and EL are the same. They're congruent. So that's what I'm going to write as my statement. So if you're talking about midpoint, you're saying that two segments are congruent. Or we're talking about midpoints or segment bisectors or something like that. Remember that shortcut from last week when we talked about alternate interior angles? Put arrows on the lines that are parallel to each other and then connect them with a Z or an N, however you think of it. Connect them with like a Z or an N. Okay? Your alternate interior angles are the corners of that N or that Z. Okay? So what are my alternate interior angles? R and D. Okay? So we would say angle R is congruent to angle D. And then the last one, 4 vertical angles are congruent. Well, remember the vertical angles are just the angles in the middle. So if you not sure how to name them, at least mark it in your diagram, and that will let you get number 5. If you're not sure how to name it, or if you misname it, still mark it, and that will help you get number 5. I'll name the first one. I'm going to call it angle RLW. I went from 1 to 2 to 9. Angle RLW is congruent to, how do we have to name the next one? RLW, 1 to 2 to 9. BLE, 1 to 2 to 9. Oh, what am I doing? Wrong one. Angle BLE. So then look at how we marked our diagram. Which shortcut are we going to use? Angle, angle, side. We have an angle. We have another angle. Then we have a side. Angle, angle, side. Again, it's not angle, side, angle, because if you go the other way, we skipped a side and we skipped an angle. So we skipped 2 things. We can't go this direction. We have to go that direction. Okay? Done. So by just knowing those freebies, you filled in most of that proof. Just remembering those little shortcuts. Okay? Try another one. Okay. And this one has possible reasons and statements to help you out. So we take a look at number 3. It says complete the following 2-column proof. Okay, we're given that angle D is congruent to angle F, and that GE bisects angle DEF. So they took care of writing our first statement. We're trying to prove that GG is congruent to FG. They took care of that. They wrote it as our last statement. Okay. We talked about this at the beginning of the lesson. What's different about this proof compared to like last proof and all the other proofs we've done? It's a little bit different. What do you mean? Elaborate. What do you mean? Okay, I like what you're saying, where you're going with that. But what's different about what we were given and what we're trying to prove compared to the last proof and all the other proofs we've done? Look at what we're trying to prove here, and what are we trying to prove this time? What? Yeah, good. Instead of proving that triangles are the same, we're proving, and pay attention back there, looking at our phones and giggling. We're trying to prove that segments are congruent rather than triangles. We're proving parts. Okay? And whenever we try to prove that parts are congruent, this is another freebie. Your reason is automatically CPCTC. Every time. Proving parts, CPCTC. Every single time it's a freebie. Every time. Another freebie. Whenever you are proving parts congruent, the one above it is automatically stating that the triangles are congruent. Because in order to say that their parts are congruent, you have to say that the triangles are congruent. So another freebie is that one. That has to be statement number 4. Has to be. Okay. Automatically. Another freebie. And then your answer has to be one of these 4. We don't talk about HL anymore. You just ignore that if you ever see it. It has to be one of those 4. So you have a 25% chance of guessing and getting that one right. You know it has to be one of these 4. Okay? Another freebie. Okay, I notice reflexive property. Whenever you see reflexive property, what does that mean? As the statement. We use reflexive property when something is what?
Congruent to itself.
Congruent to itself. Yeah, so I notice here I have reflexive property. So I know I have to put something is congruent to itself as that statement. So it's one of those 2. But we can narrow that down. Because what type of triangles are these? You were getting at this before. What type of triangles are they? They're shared side, right? They share a side. And whenever you have shared side triangles, you always have to say that the shared side is congruent to itself. So that means this one is the one that's going to go in number 3. GE is congruent to GE. Done. Just recognizing those freebies. You filled in almost this entire proof. But there's another freebie we have that we haven't done yet. Okay. If we go back to our given information, they said that D is congruent to F. They marked it. So we took care of it. We don't have to mark it. And then it says GE bisects angle DEF. So what is our reason for number 2? What is that going to be? definition of an angle bisector. If you look in your box, it says angle bisector. That's what we're going to write. Okay. Just getting those freebies down. You filled in everything but two things. And you could have filled in number 4 and have a 25% chance of getting it right. Okay? By just noticing those freebies. Or remembering them. Okay? Well, we know what to put. Whenever we have an angle bisector, that means we're cutting an angle in half, right? So it says that GE is cutting this big angle in half. So then what do we know about those two little angles? They are what? They're congruent. So I at least know whatever I'm putting for number 2 has to be talking about angles being congruent. So I know this isn't right. Does this make sense? Angle is congruent to itself. What did we say our reason is whenever you have something's congruent to itself? Yeah, that doesn't go. Yeah, it's congruent angles, but that doesn't work out. So at least now, 50-50 shot. But which one of these are naming the right angle? The first set or the second set? Second set. So that's what's going to go with number 2. Angle DEG is congruent to angle FEG. The first set is naming DGE, D to G to E. It's naming this angle right here. Well, we want these two angles, so it's not naming the right angle. So we know that can't be it. Well, oh, we forgot to mark the shared side congruent to itself. That's why it's important to mark your diagram. So looking at our diagram, which one of these shortcuts did we use? Did we mark 3 sides? No, I didn't mark 3 sides. Did we mark 2? Girls, please stop, please. Did we mark 2 sides? Did we mark 2 sides? No. So by just thinking that way, you ruled some of them out. So which one does it have to be? Angle, side, angle, or angle, angle, side? Angle, angle, side. We have an angle here. Then we have another angle. Then we have a side. Angle, angle, side. Done. Questions over there? Okay. Get out your 9.4 practice. Try to get at least like one of those passed.